Hey televisions, back with me again, Ajiga Utamakotada. I'm your lecturer for parallel and distributed systems. This is the 10th meeting about parallel programming design. In this next video, we will discuss about data dependency and load balancing. So we have discussed about four of these discussions. This, and now we are going to discuss the last two, which is data dependency and load balancing. So data dependency is easy. It is related to communication. So if there is many communications, it means that it is data dependent. It means that between different tasks there is a high dependency, and if there are no communications, it means that there are no dependencies. So for example, here we have an image, a black and white flag, a checker flag, and the task is to flip the black with the white and the white with the black, and we divide the picture into several tasks. For example, task 0, task 1, and task n. So if task 0 wants to flip white with black, does it need to communicate with task 1? I don't think so. It just needs to convert black to white and white to black. So this is an example of no data dependency. And secondly, to create a heat map. A heat map means that in this sensor, it is the most hot spot, and as it goes to the edge, it goes colder. It means that between task 0 and task 1 here, task 0 needs to communicate the heat of task 1 to know the heat of task 0. This means that mm, through this barrier with task 0 and task 1, there is a communication. This means that making a heat map is data dependent. And load balancing. Load balancing means that if we have several tasks, is the load even, or is it not even? An illustration here is if we have a highway and there are two ways in the highway, and everyone is going from one direction to the second direction, and no one is going from the opposite direction. It means that the load isn't balanced. So we have two resources, but the resources aren't used in the same with the same load. So in our example, in this road, usually you do counter flow. Counter flow means that if there are no one using this side of the road, just go one way. So the load is balanced between this road, the left road, and the right road. So load balancing is like that. If the load is not balanced, you need to make balance by creating a system. So we have discussed several examples of parallel programming, and as you can see here, actually all of them are quite balanced in load. If there's an image and you divide the image into equal parts, they are balancedly load. And if you have an operation, a mathematical operation, for example here, 8 factorial and average calculation here, if they have the same amount of numbers, usually they are divided into the same amount of calculation. So usually our process are balancedly load. So in simple examples, I don't think load balancing is a high concern. So that is the end of video 6. In this video we have discussed about data dependency and load balancing. In the next video we will discuss about an example of gathering all of the components together. Thank you for your attention. I'll meet you in the next video.